very basic. This is very basic in the sense that if you have used the terminal somewhat and you have been using it for a while, you might feel a little bored. So I'm warning, not a warning, like I'm in advance, I'm telling you that we'll be doing very, very basic things because that's the sort of intention of this lesson. But even if you're an advanced user, you might time to time get some tips on certain things. So to start with the lesson, I will show the HackMD here. So Radovan, when you have this HackMD, do you have it on the edit mode, view mode as I do, or do you have it on the edit mode by clicking on the pencil, or do you have it in the split mode? Which mode do you prefer and why?
So I personally have it on edit mode. I recommend also everybody to actually switch to edit mode at least once. If you then prefer to follow it in view mode, it will, we have seen that it sometimes doesn't update if you haven't switched to edit mode at least once. So I recommend everybody to switch to the edit mode. I think we also have a question for everybody to get started so that you can practice how editing this document works. And if you are new to this, it might look unfamiliar, but there is not very much we need to learn about this document. You can write text as is. We have an icebreaker question, and the icebreaker question that Sabry is sharing is, what is the most important thing for you to get clarified about the Unix shell today? And here what I will do, and please do it as well, you can go in and edit. So I can write in what is the important thing for me to clarify.
So Radovan, when you're editing, is it okay for me to edit as well at the same time, or should I wait for you?
No, absolutely. We can all edit at the same time. We are now 35 people in the call. At times it might get a little bit chaotic, but it's good. This document can handle up to, I don't know, we had 300 people on one document. And this would be very nice for us to hear what is the most important thing for you. And hopefully we will get that today. You will also notice that below this icebreaker question, we have place for questions. So later, as you have questions, you can add them always at the bottom of the document. And we have a number of colleagues who watch this document and will help answering these. And we will also see that this is really great. We can ask questions in parallel and we can answer them in parallel. And when you write in this document, don't use any names. Let's keep this really anonymous. It will be also easier than to ask these questions, and it will be easier for us to publish these. Maybe we should also say that about the recording, because people have maybe noticed that we have started the recording button. We are recording this session. We will put it on a public space. So to make sure that you don't appear on any recording, make sure you are muted and maybe turn off your video. The instructors will keep video on. So just wanted to mention that. Sabry, you wanted to say something?
So Radovan, the dash at the beginning of each sentence, is it important to have it? And also the numbers in the questions, what is the significance of that?
Yeah, the dashes in front of they create a list. So if you switch to view, you will see that these dashes create like a bullet list. So these are the dashes. And the questions we recommend to put a number in front, because then sometimes we will get the same question asked several times. And then we can refer that, yes, interesting question, but look at question number 17, because this was already asked and there is a nice answer there. So it makes it easier for us to refer to other questions.
So thank you, Radovan. So I'm going to switch back to my teaching material, but our colleagues, they are following the HackMD, and please keep on using it. And if you have any questions about it, we can help during the sessions. So is there anything interesting in the icebreaker questions that is there anything that we could sort of take up as an interesting expectation?
So a few things that are mentioned here. will be, we will teach tomorrow and on Thursday. So today really it's, so there is a question about Git, question about modules, how to find, how to, question about, so goal with running bioinformatics. So these are things that we will discuss in following days. Today, really the focus is, what we want to learn is how can we connect and how to move around to get the basics of Unix command line. How to move around, how to create files, how to read files, how to move files. So this will be the focus today.
Yes. So the basic tools and the know-how for the next few days, we will get it today. So I guess everybody has a link to this page. So if you don't have it, one document you can always fall back is this HackMD, where there are links, the course page. So if you get lost, you can come back here and find the links. So in the course page, the first lesson we have is about some basic understanding on how to log into the cluster itself, and some understanding on to see why we need to learn these things, sort of a motivation for ourselves. So if I tell you a little bit about the plan, Radovan. So in this first lesson, there are no exercises. But when I do certain things, we expect the learners to follow on their computer as well. So we call them like type along. So Radovan, sometimes when I'm type, I might forget to mention this. So maybe you can help me with that if I do that.
I will do so. And we have, what we will try today is this co-teaching model. We will be always two people talking, a little bit like watching a sports commentary where there are typically two people in the TV studio. Also, we should maybe say that you might have noticed that Sabry's screen share is portrait mode. It's narrow, it's upright, it's not landscape. And the reason for this is that one way that you can participate is that you put your Zoom screen share on half of your screen, and you can use the other half to have a terminal open and type along. And I will then remind everybody when is a good moment to type along with Sabry. You can also use the other half of the screen to have the website open if you want to, and check that we follow what we have in our material. So that's the other option.
So today's lesson, we expect that everybody to have an account on one of the clusters, Saga, Betsy, From, or one of your local clusters, if you prefer that. But even if you don't have an account, it is possible to sort of follow the things we teach today on your laptop itself. But there might be some consistency issues in the sense that you might not see the exact same thing our instructors are showing on your laptop. So we recommend that you log into the cluster with your one of your clusters, preferably Saga, in order to follow the lessons. So now we have the HackMD open, Radovan. So rather than we go deep into sort of why we need Unix or a command line terminal or a shell, or there are so many names that are referred to, we shall have a look at how we interact with the computers in general. So Radovan, if you want your computer to do something, let's say open a document, how would you ask the computer to do that for you?
If I open a document, I would, even on my laptop, I would actually open a terminal. But the alternative that I sometimes use is I open a, how is it called, a navigator. So on my computer, it's called Nautilus. It's a graphical navigator where I can see the folders, the files, and I can left click on them and right click on them. So these are the two ways.
Yes. So open the document, and while we're talking, you could, if one of our colleagues could place this question there, what are the methods you know that you can use to interact with the computer? Like, how would you ask a computer nicely, can you do it for me? Open this document, save this document, send this email, find me a file. At the moment, it's not like if how you would do it in a technically perfect way, but how would you today do is, please write that down here on the HackMD. So we'll continue our discussion while this happens. For example, these days, Radovan, so I have my phone here. So I have this search box here, and I have this microphone. Let's see, yeah, that icon. So I press this and I ask, okay, it's already start searching. What is a Unix shell?
According to Wikipedia, a Unix shell is a command line interpreter or shell that provides a command line user interface for Unix-like operating systems.
You could even today talk to computers, Radovan. So you can just ask things from the computer, from your phone, do this for me, do that for me. So there are so many ways of interacting with the computer. So is there anybody? What are the? Yeah. So I don't see anybody typed anything yet. We'll come back to that when it's ready. For example, you could use your mouse, interact with the computer, but it would be very, very old times. You use like punch card systems and so many ways to interact with the computer. So this command line interface is also a way to ask a computer nicely, do certain things for me. So it's another way to interact with the computer itself. Not like a let's say a completely different program or anything. It is just another way to interact with the computer. Is there anything else, Radovan, you want to mention about the CLI or the command line interface we talk about?
Yeah, we will introduce it now in a moment. We will also motivate why we actually go to the command line for the rest of this session.
Yeah. But these ways, for example, talk to your phone or use your mouse would be difficult if you want to sort of do things. Some examples are mentioned here. Let's say you have 1,000 files, many files that you want to rename all the files by prepending the word latest in the front or a date in the front. So this will be very cumbersome if you want to do one by one. And then let's say there's a folder with so many image files. Some of them are PNG, some are JPG, some of them SVG, and so many different files, and they have extension. And you want to group them into subfolders using this extension. And the third example shown here is extract the first 10 lines of the first 100 files or some number of files and create a new file from that. Another example is, Radovan, I don't know you are familiar with this bioinformatics text files, for example, FASTA files. They are starting with this, yes. This particular sign. If you want only to extract the title of it and create another file, if there are millions of lines, count how many lines are there in a file, just peek on certain parts of the file. This might be very difficult if you use methods like clicking, using the mouse, or talking to the computer.
Very good point. There are a very good point, and that is if we need to do similar tasks on many files, then it starts to become a little bit annoying to right click on each of these 200 files. The other aspect that was maybe not mentioned here is reproducibility. Of course, I can go and manually spend 2 days clicking on all these 200 files, and maybe I know how I did it. But what if then somebody else wants to reproduce my research a few months later, and the somebody else might be me a couple of months later? Then we will see that this is the moment when the terminal and command line and scripts, this is the moment when they shine, because they make reproducibility easier. So these are for me the two aspects: automation, reproducibility, easier to share what we did.
Yes. So then we talk about this working on a remote computer. I'm going to scroll a little bit down and come back again on this document to show a diagram. So this is sort of how we would work on a remote computer. You have your laptop, and then you have the internet between your laptop and the computer, which is in Tromsø, for example. And you will use the internet to connect to it. You will use your keyboard to send instructions to the cluster and then get the results back via the internet. So these sort of instructions are more intuitive, more easy to work with if you just use the terminal without a graphical user interface, as we call it. But there are you could also use a graphical interface to interact. I'm not saying that you should do it, but for basic tasks, it's very convenient. And then later on, Radovan and Jørn will be talking about pipelines, and you know, this Unix comes with a set of commands that you could combine to make your own pipeline. So you could if you have a certain task which you could not achieve by a single command, you can combine multiple commands in order to achieve that task. That will come very, very soon. So first thing, Radovan, is to find your terminal on your laptop. So first we need to find our terminal on your laptop. And our colleagues, please paste this question before I start talking. So to vote, if you have already found your terminal, a way to inform that. And if you cannot find your terminal, another to inform that us as well. So what is a terminal is the first thing. So the terminal is a program that we use to interact with this command line interface. So usually on Unix computers, there's a shortcut. If you press the control key, Alt key, control key, and the T, it might pop up. Another is on the Windows, the search button. So Radovan, today if you are using Windows 10, for example, you could use the Windows command line interface, the CMD, even that one to use the we can use that to issue our first command SSH that we're going to learn later. And if you're on a very old version of Windows, not very old in the sense like Windows 7 early versions, you might have to install a certain software which Dania had sent you a link, which is called WinSCM. So please try to, yes, go ahead.
Sorry, just to clarify, can we show people again how can they find the page that you are on right now, just in case anybody is lost of, I think yes. we can assume that hopefully everybody is on the HackMD, but how can they find the page that you are presenting?
So the only way I would recommend is come from the HackMD. Go to the course page from the HackMD, because I could show you this link, but then there'll be one more link for you to remember. So I recommend get the HackMD and from there to navigate. Is that okay, Radovan?
Sounds good. We have 5 votes, which means that either people are still working on it, we should give them more time, or that maybe it's not clear how to edit HackMD. So it can mean many things now, but we have only five people have voted that they have found terminal on the computer. Hopefully okay. It will be nice if it sums up to something close to 30.
Yes. So on Mac, I see this screenshot. You have this the place where you search for things, terminal. So you could have that as well. So we'll give another 2-3 minutes for people to find the terminal. While that happens, Radovan, so I'm going to, okay, maybe I should wait.
Yeah, let's wait just a minute of breather. Also, at the bottom of the HackMD, keep the questions coming. So far, we got none. It's a great way to ask questions really semi-anonymously. Every question is a good question.
So while that's going on, I managed to find a Windows instance. Oops, it went full screen. So Zoom is covering certain things. Let me make it smaller. So here this search button. So I could type terminal, and it will actually open the Windows command prompt. But if it is Windows 10 or newer versions, we could also use this. So I went there, I typed terminal. And if you have WinBash, I don't see that I have installed WinBash here. Yeah, then you can use that as well. So I will keep this Windows as a backup to show you if later on if we need it.
And this is very important because the rest of this morning we will encourage you to type along. We will have exercises, and if you can't find the terminal, it will be very hard. So that's why we spend some time here on finding the terminal, and then later we will also spend some time on connecting to the cluster.
Yes. So in order, Radovan, to keep the flow, shall we have another voting option saying that we are just passively following, that we are not looking for the terminal at the moment? So we could have just an idea about if people are still looking for things, or they will they are lost. So yeah, only watch the course. Check the participant numbers and let me know when there's a reasonable answer.
Well, we have like half the people voted, but typically not everybody actually edits the HackMD. On the chat, on the Zoom chat, you can find the link to the HackMD document, which everybody can edit. Top of the document, there is an edit button.
So for the sake of time, I'm going to go to the, so I have found my terminal. So in this terminal, Radovan, I have this prompt. It's because this is my laptop. So this is my laptop prompt, and it could be different in your laptop, or if you have WinBash, it will be different as well. So we have this cursor at the end. This is where if I type something, that is where it will start appearing. And in Windows, sorry, on the terminal, there are sometimes that when you type a command, it might not return anything, but it might do certain things. We'll come back to that later. So the first command we are going to learn today is the command SSH. That is to connect. That is the command we use to connect to the cluster. So the SSH is a protocol in general. A protocol is sort of like a established rule to how to do things, Radovan. But today, when we refer to SSH, we will refer to the command SSH, which is really a client. Which means that it could connect to another computer which run this SSH server. So we don't have to worry much about it. But whenever we use SSH today, it means the SSH client program. Does that make sense, Radovan?
Makes sense. And why is it called secure? So what is the secure part of it?
Yes. So the secure part is when you go connect to the cluster through the internet. As you said, you don't want people eavesdropping. You don't want people stealing your data. So it sort of encrypts. So it makes it like mashed up. So the information. So only the sender and the receiver would know what exactly it is.
Yeah. So it is really end-to-end encrypted.
Correct. And then to find out the SSH, so I'm going to use, if it is Windows prompt or WinBash or Ubuntu or whatever it is, SSH and a capital V, a big V.
And here we encourage everybody to try that as well. And I'm trying this also on my computer.
Yes, please do that. I will try to do that on the Windows machine as well. SSH capital V. So it should return something, open SSH for Windows, or some sensible message. The error message would look like something like command log not found. So can you prepare a place for people to vote for this on the HackMD, so we'll have some idea?
Yes, working on it. Just asking myself where I should put it. Maybe under the questions or on top of the questions.
After the first survey, so right below the survey would be good.
All right. Yep. So let's make another one. Is available on my computer? Yes, and actually I vote yes because on my it is. No.
So I like it when the yeses are bigger. So no's means we might have to help people who say no in a breakout room, for example.
But we are happy to help. We have breakout rooms, so also don't hesitate to write no if it's not working. It's not your fault. This is not easy what we do here. It's a new thing.
So I'll take up my Windows one again. Is exit working on Windows? Yes. Terminal. I type the terminal here. I found this command prompt, and I said SSH dash capital V. If I use a simple V, it will not return that version. Let us say capital V. So one thing that you will be probably emphasizing a lot later on as well, this case is very important in Unix. Smaller case SSH does not mean the same thing as uppercase SSH. So if I type SSH dash V, that command does not exist around.
Good point. So now that we have found SSH on our computer, what can we do with it?
So we are going to establish a secure connection to Saga using this SSH program. So first I have to call the SSH here. So I'm going to use a command called clear to get some space on my monitor. Then I would say SSH. Then I would have to introduce myself around. So I had to say, this is my username. This is the username we got from Saga. My username is Sabry. And you should use your username. If you try my username, you should not be able to log in. So if you will get an error. So you have to use your own username. And that means I'm introducing myself, and I'm going to log into Saga sigma2.no. So this is the address of the server. So when I press that, it will give me a warning message. If it is the first time you're logging in, if you had logged in before, it will not pop up. This says that you're going to establish a secure connection to a place that you have never visited before. Are you sure you want to go there? So should I press yes or no, Radovan, here?
So I recommend to press yes, but I also want to say that if people want to verify that the machine is really saga.sigma2.no, in our documentation, we have these fingerprints. So a little bit up there is a fingerprint, so one can verify that this is really the machine that we are talking to.
So then I have to type the password. The thing with the password on Unix, when I type the password, it will not appear. So people will not see it.
That's a good thing, because then we don't see really how many characters you have.
Yes.
So it makes it easier.
So, yep. Yeah. So if you type the wrong password, it will ask again. I hope I will remember my password, Radovan. So once I type this password the second time, because when I typed it first time, I maybe have had my caps lock on, maybe some character I missed. It will say try again. Now I'm inside Saga, so it will give some details, some operation logs, and some intro. So Radovan, when you are here, you will see that my prompt has changed from my earlier prompt, which I had. If I go up from my laptop prompt to Saga prompt. To make sure, Radovan, I always use this command host name to make sure that I'm on Saga.
Yeah. And can I ask where is Saga? Like, where is it? The actual machine?
So the actual machine is in Trondheim, right? If I remember correctly.
Yes.
Yes.
So now we are all connected via end-to-end encryption. If you followed along, we are connected to a cluster that is sitting somewhere in Trondheim.
Trondheim. And then after logging in, Radovan, if you want to come out of the cluster, go back to your laptop, you should type exit. And you could verify that you are again with the host name that you're on your laptop. So Radovan, we learned 3 commands now. One is the SSH to connect to the cluster. Another one is host name to find out where you are. Because if you fail, for example, here the password, I typed the wrong password and I landed back on my laptop. So if I type things that's I'm supposed to type on the Saga cluster, it will not work. So you have to make sure where you are. Then I type the exit command to come out of it. Radovan, how is the HackMD? So there's one SSH no. So Dania, can you help that person to get into a room now, or how is the plan, Radovan? Now my presentation on this first part is done.
Yeah, so we are now perfectly well on time, but it is important that we now help everybody who has trouble logging in, because the rest of the course we will do on the cluster directly. And if you can't log in, it will be difficult to type along. You can still, of course, watch us work, so you can still participate in the course. I'm looking through the questions. Yeah. Some people got, or I get permission denied, but then the person made it into the machine. Good. And the problem was that when we SSH into the machine, we typically have to use your username, so not Sabry's username, add the name of the computer. In this case, it was saga.sigma2.no.
Okay.
And I have to make some announcements, Sabry. And Marius has fixed the 3 of user application from yesterday, and they might have got some message on already now. So the user application thing is fixed. And even then, if anyone else don't have access, that means they didn't apply for the user account. And there will be breakout room after Radovan's next sessions. Then they can fix if there is something with this permission or something. So rather than going to a breakout room now.
Okay, so no
then expert helpers will help them. Yeah.
So Radovan, I'm going to stop sharing my screen so you could take over.
That sounds good. Let me take the screen from you, because this way we don't expose anybody. We don't expose the Zoom gallery on the recording. Just a sec. All right, I have some screen share. I need to adjust it a little bit. Good. The plan now is we are 40 minutes past 9 o'clock. And we will go for 15 more minutes, and then we will take a break. After the break, we will do our first exercise. I want to now show you how you can find where I will be right now. This is the HackMD. This is where we take notes, ask questions. On top of the HackMD, there is a link to course page. I will follow that. Let's see where I land. Course page. This is happening today. Day 0. We have now introduced, and I know that the font is a little bit tiny, so I will I will zoom in. We have now with Sabry introduced the terminal and how to log in. Now that we can log in, I will show you how we can navigate on the cluster and how we can have a look at files. So that's the plan before the break. After the break, we will do more of this, but then we will exercise some commands that we now learn together. And if I understand correctly, now Jørn will assist me and to ask me some questions. So what we are to get to today 3 instructors, Sabry, Jørn, and me, and we will be cycling around and helping each other out. I will now go into navigating on the cluster. Good. And what I will do is I will open this page also on the other half of my screen so that I can use this half to share my terminal with you. Okay, just need to arrange these different Zoom windows here. My goal now, before the break, show you how we can navigate through folders, how we can create folders, copy, move, rename, remove files, and we want to be able to see the contents of files in the terminal. Oh, I hear some music. Jørn is here?
I hope so.
Yes, hi Jørn. Maybe we should Maybe we should introduce each other here, ourselves. Yes. So Jørn and me, we are working at the University of Tromsø, part of NRIS, and we will be taking you through this episode together.
Yes, I'm looking forward to it.
Good. So please ask me lots of questions. Jørn will also help me looking at HackMD and raising anything that I missed. I want to show you one more thing before I move the browser away. And that is that if you want to type along with me before the break, you can get exactly the same files that I have by running these 4 commands on Saga. And we didn't really explain yet what these commands do. What these commands will do is that we will fetch some example directory and I will extract it and we will go in it. So if you want to type along, copy these into your Saga terminal and I will do the same thing on my Saga terminal. Here I'm on Saga.
So Radovan, a question that I see that in my the prompt it says login 4. Does it matter or is it okay? Okay? It says Bast at login -5.
Yeah.
Does it really matter what it says there?
No, that's okay. It's okay that we are on, because on the Saga cluster we have actually different login nodes, so-called nodes. These are different computers. So when you log in, you will, I think there is a round robin. So we can all be on different machines, but we still see the same file system. All of them are connected to the same file system. So this is fine. It's fine that it looks different. Also, this will look different.
The other one, what did you just do?
What I did is I copied these 4 commands directly into the terminal and I pasted them in.
And so now you have the same files as, well, like everyone can get the same files as you do.
Yes, it created a folder called demo moving around, and everything that I will show in this folder in case you want to do the same thing that I do. And what you can see is that I have now, on top I have the browser, I will move it away to have more space. I have my Saga terminal here. And I will also, down here, I will show, you will always see the last command that I type. So I now typed these commands. Well, I copy pasted them. So I will give you just a minute to catch up. And in the meantime, I will move this, I will move away the browser to have more space here.
Do I need to have the browser open on my computer as well?
You don't need to. You can have it open if you want to check that I didn't forget anything. But I actually recommend to, because I will show what we have in the browser. I will show actually less because I don't want to show everything. So if something goes too fast, you can always read it up later, but maybe the best experience is on half of your screen, you have my terminal open, and on the other half, you have your terminal open, and you try to type along. Maybe that's the best experience.
And all these commands are you now write on Saga, so not on your home computer.
Yes. And how do I verify that? I verify that, whoops, hostname. I'm here somewhere on Saga, on login 5, and maybe you see login 3 or 4. The other command that we can learn right away is pwd. This is a command that I use often to find out where I am. Where am I on the cluster? This is print working directory. And it tells me that I'm in this place. So this is the file system. Mm-hmm.
So Radovan, why is it so cryptic, PWD? How do you remember this? What PWD means, and why is it so short? And why doesn't it say that find my files or something? Where am I?
Yeah, great question. We will learn a couple of commands today, and they will often be very short, sometimes cryptic, sometimes non-intuitive. And the reason is that most of the commands that we show today have been introduced in the 70s. They are 40 years old. They are still around because this is still such a good system. But at the time when they were introduced, I mean, screen space was very, very limited. Sometimes the screen didn't even exist. And some of the commands also were introduced because, I mean, Unix was developed initially by 2-3 people who worked in the same corridor. And then somebody created a command over the weekend and found it useful. And then colleagues started using it. And then later, the person felt bad changing the name because 20 of their colleagues already used it. Well, today, hundred thousands of people use it. So, but it's too late to change these things. But so they are short and sometimes cryptic. How do I remember it? Well, the goal of today is not to remember the 10 or 15 commands that we will introduce. The goal is that you know where to find them. You get used to them over time. So we recommend to try to get them into your muscle memory over time. If I use them once every week, then I remember them like this.
I think it's also a good idea to just like note them down on a piece of paper. So because you can write down the explanation for the command best that suits you.
And one thing that we could do, if people feel like it, in the HackMD, we could create a list where we list all the new commands that we learned so that we have them all in one place. And then we have a little reference. So pwd is one of them. The hostname is another one. Also, you notice that everything is now that I'm on Saga, everything is black and white. And this is, you can add colors. I have not added any colors here because I wanted you to have the same experience that I have so that it doesn't look different. But I can mention that it is possible to add colors and to make it a little bit easier to read. So we have hostname, we have pwd. The other command that I use all the time is ls, which will list what is inside my current folder.
Radovan, someone had problems copying into their terminal because the usual control V didn't work. Or pasting into the terminal. Do you know what you can do about this?
Yes, copy pasting is different on different machines. And the way I copy pasted it is that but I don't know whether this will work on Windows. I don't know. I can tell you how I copy paste it. Is that useful? Maybe. So
it works with the mouse right click. But please, could you repeat again how you got here? Because we have several questions. They missed that we switched to the next page, and they don't find the code which they have to copy and paste into the screen.
Yep.
Of Saga. They're still in the previous page of the tutorial.
Exactly. Yeah.
Thank you.
let me do that. I just need to have a browser here. Wrong. Oh, how can I like this? Here, a browser. Make some space here. On top of the HackMD, there is a link to the course page. I click on this. In the course page, we are now in navigating on a cluster. I click there. And here, if you want to get the same files that I have copied these 4 commands, and I think you can copy by clicking up here, copy to clipboard. And now you can paste it into a terminal. Let's see how. Well, I don't want to do it again here. The way I pasted it is I pasted it on clicking on my mouse wheel.
Yeah, but you can usually right click and it works. Because the typical control C control wheel don't work. There are reasons that we might come into it, get to them, but yeah. Control C has a different meaning in the terminal. So
yes,
just use right click. This is the easiest.
So if you created this example, you have a folder that is called the demo moving around, and I stepped into the folder with cd. Cd is another command that I didn't really introduce yet. Maybe I should. So what have we learned?
What does cd do?
So with cd, I can change directory.
So is it cd change directory?
Yeah, cd. So I can go, what if I want to go back? What if I want to go 1 level up? It's cd ... Now I'm back in the same place where I was when I connected to Saga. If I want to go back into my demo moving around, I do cd demo moving around.
Okay.
And if I want to double check.
Can you show us again, where you are currently? Okay, this PWD, you can always check where you are. And each of these slashes is 1 level. So the first level is the first folder is cluster, then there's a folder home, then a folder bus, demo moving around. So you are now 4 levels down.
Yes. And we are very close to the break. Maybe a few more commands.
Yeah, how do you know? Now you're in a folder, but how do you know what is in the folder?
Yeah, it's ls. Maybe a little bit more details is ls -l. It's the long form. Most commands in Unix have options. ls has many options. This is one option, -l. There is another option, h. I can even put them together. And this will print the output. So instead of telling me how many, it will tell me in kilobytes. So it's easier to read, human readable format.
Does it matter which way around this? Is it -lh the same as -hl?
Doesn't matter. I can also do this.
So I don't have to memorize which way around.
No, and I often don't remember all the different flags and the options. Sometimes people call these flags. If I don't remember and want to see what are the different options that ls has, I can open up the manual. So there is a command called man, short for manual, and I can ask it on any of the commands that we learned today. Enter. And now I can scroll down and up with an arrow, down and up. And here are lots of different options that I can use together with ls.
It looks a bit confusing, I have to say. There's so many options.
It's overwhelming. What I often do is I scroll to the end with, do I have a page down here? Page down to the end. Often at the end are examples. but it can be a little bit overwhelming. I should
Do
also
you have
show.
Do you have to know all these different flags or options?
No, I know only a handful of them, and I think it's impossible to know everything. This is useful if you also see an option and you are not sure anymore what does it do. Then you can go in here and find out what does this option do. And if I want to get out, there is Q. So it tells you press H for help or Q to quit. I want to quit. Q. Oh, wrong window. Here, Q.
So, okay, and ls you use to do what? What does it list or what does it do?
It lists the content of the directory. It lists the files and directories.
In which directory are we now, or which folders does it list?
It lists the one where I'm right now. I can also let it list. I can ask it to list any other folder. So let's see what is in this home folder of mine. There are some other files.
Yeah, I have to say I was a bit confused because now you used CD1, so you went down into one folder, but suddenly we are like there's like so many folders above. So there's cluster and home and bust. Where did we start when we logged in?
We started. Let's try. Let's open a new terminal. I'm now on. This is colored and this is my laptop. So when I logged in to Saga, where did we land? I landed here. This is my user space, my home space. Okay.
Mm-hmm.
I will.
Radovan and Jørn, we are reaching the break soon.
Yep.
So yeah.
So can you finish it in 5 minutes or 3 more minutes?
The whole episode? No, but because
yeah, I understand.
I think it's good time to take a break. I think it's time to restart.
Yeah.
So
yes, please.
I'll come back from the break. We will do a few more minutes, show a few more commands, and we will then take good time, 15-minute time for an exercise. The exercises we will then be in Zoom breakout room, but I will tell you then how to use the Zoom breakout room well. A little recap. I'm on Saga with PWD. I'm in this place. With ls or ls -l, I can list file contents, the directory contents. In this example, there are some directories and some files. How do I know? There are these things in front of it. We didn't really explain, but the first character is a D, or there is not a D, and everything that starts with a D is a directory. So there is a directory called another folder, and a directory called some folder, and then there are some other files. And what we did before the break with CD change directory, I can jump around the file system and go into different places. With CD ... I could go one level up, but then I can go back into my demo. And if you are somewhere deep down in the folder and you want to go back to your home folder, you don't have to do CD ... and go back. If I type CD without anything and enter, it will bring me back to the same place where I was when I SSH'd into the machine.
Well, how would I go down multiple levels at once or up?
Like this, moving around, and then I could go into some folder, for instance.
Also, you are super fast at writing. How do you do that?
Oh, I didn't. I'm sorry. I actually wanted not to use it, but I'm so used to it that I do it automatically. So what I do, let's do that again. I go back, CD. What I do, but I did it automatically out of my muscle memory, is that I type the beginning, And I know that there is a folder that starts with this name. And instead of typing it out, I hit the tab key on my keyboard. So top left, there is the tab, and it auto-completes it. And again, here, I know that there is something that starts with some, and I don't have to type the whole thing. I hit tab.
So tab is the key with the 2 arrows in opposing directions on the left side of you.
Yeah, and it auto-completes on Unix. It will auto-complete paths. You can even let it auto-complete commands.
But in CD, could it also auto-complete a file, which then doesn't work?
You can let it auto-complete also the file. In this case, it would be a bit weird to change directory into a file. If you want, we can try. Let's see what happens. What if I want to change directory into poem? Oh no, it doesn't. It doesn't autocomplete. Interesting.
So autocompletion is actually sometimes quite intelligent and only like autocompletes the things which actually make sense. So you can autocomplete a folder with CD because with CD you only change folders.
Yeah. So now that we know how to move around, let's do some things with the files. One command that I wanted to show is sometimes you need a new folder, and I can create it with mkdir make directory called new folder. And here it is. So there is now a new folder, and there is nothing in it yet. We need to learn how to copy files with CP. I can copy the poem into a different file called, let's say, poem2.
So CP was you copy a file and then you first have the old file and then the new file?
Yes. So copy from where to where? The source, the destination. And now I have 2 files, poem and poem2. They have the same size, and one is a copy of the other. You can also copy files into another folder. I can copy the poem into the new folder if I want to. Again, from where to which destination. So now inside the new folder, there is also the poem.txt. You can even copy multiple files at once. What if you want to change the name? You can do that with move mv. So with move, you can do 2 things, and for Unix it's the same thing. You can either rename or you can move it to a different place. So if I don't like the name poem2, I can change the name. I can move the file to poem3. And with mv, you can even move it to a different place. What if I don't like the file anymore and I want to get rid of it? It's rm remove. Dangerous command, because on Unix we often cannot go back. I don't like the poem3 anymore. I want to remove it. rm poem3 text, and now the file is gone. And if I want to remove a folder, I need to use rm-r. And if you want to find out what does the -r do, how can I find this out? You can ask the manual man rm. There will be lots of options. One of them will be -r, and you can find out what this does.
What would happen if you want to delete the folder but you forget the -r? Because I mean, this is all, I can't remember all these commands at the same time. So I remember remove for rm, and then what happens if I want to remove the folder but I forget that there's a -r?
Yeah, so what if I forget? Let's try it out. Let's try to remove another folder. It will tell me that it cannot do that. It is a directory. So for directories, I use this option.
But there's no trash bin.
There is no trash bin. So if I remove it, in Unix, there is no trash bin really. Fortunately, on Saga, we do back up your home folder. So if you accidentally remove something, you can contact support, and for a couple of days, we can recover it. More about storage and backup, I think we talk on Thursday. I would like to show 3 more commands, 3-4 more commands, and then we go into the exercise. Now we know how to navigate, how to copy files, and I don't expect that you remember all these commands, but you know where to find them. I'm now following exactly our website. What if I want to look at one of these files? What is in the poem file? I like to use the command cat. This is not, it doesn't mean the animal, but it comes from concatenating files. You can use it to concatenate multiple files, but many people use it also on one file only. And then what it will do, it will print the content of this poem directly into my terminal. On the website, I offer several more options on how you can look at the file contents. You can then try that in the exercise. I want to only show 2 of these. One is head, and the head shows only the beginning of a file. And how many? I don't know, 10 lines or 15 lines. And you can, if you want to see only the first 5 lines, you can do it like this. And the opposite of head is the tail. It shows you only the end of a file. So here I don't see the entire poem, only the last 2 paragraphs. And also here you can ask tail to only show you 1 line or 10 lines or 200 lines. And one more command for the exercise is to compare. Sometimes I want to know whether files differ and how they differ. And for this I use diff. So I can compare the file unfinished and poem, and it will show me the difference. In this case, the file differs only in 1 line in the title. If there is no difference between the files, diff will not give me anything. So that can be useful to find out whether the files are same or different. So now I threw a lot of commands at you, but let me now explain what we want from you in the exercise. I just need to open, the episode again here on my side. So what we did here, and you can use this page to recall again a couple of the commands that I showed you. We did how to copy, how to remove, how to print the content of poem, how to print head and tail. Some commands I didn't show, but you can explore them on your own. Now the exercise, 15 minutes, not 20 minutes. Note that there will be too much for 15 minutes, but it will be already really good if you can try some of the portions of the exercise. The rest, if you like, you can do at a different time. It's a good homework exercise. To work on the exercise, you will connect to Saga, go back to your home folder, and fetch this different directory called exercise moving around. And you go in, and then there are a couple of tasks that you can look at. In the breakout room, you will choose the breakout room on your own. So in Zoom, on the bottom of your Zoom window, there's a button called breakout rooms. You can move yourself to one of these. We recommend to have 4 or 5 people in each breakout room, so not too many. If you see one that is already really full, take a different one. In each of these, there will be a helper. We recommend that the breakout rooms are not recorded. So please unmute, discuss, ask your colleagues. Maybe one of you can screen share and the others can help navigating. And then you can try some of these exercises or all of them. There is also a solution. So if you click here there is a solution. In Unix, there are many solutions to each problem, but here for each of these, there is one example solution that will also hopefully also help.
Yeah, I just wanted to mention that I have assigned the entry staff to one of each breakout room, And if anyone still has some issues with the user access, please go to the user access breakout room. There will be our colleague from Sigma 2 who will help you if there is an issues with the user application or something. And yeah, I will close the breakout room after 15 minutes so that we follow the schedule. We are lagging behind. So
yeah, and it's not a problem. Like, so also the co-instructor shouldn't be worried, because in the future episode, I will then not spend so much time on the rest of the things, because this stuff is really important. We will show less, but we will not speed up. And on the bottom of the HackMD, I will paste a link to the exercise so that everybody knows where we are. 15 minutes.
May I ask a question? I have this a bullet here, join a breakout room. How do I know which breakout room I join?
you have assigned it to room number 1.
Okay,
Nicola?
Yeah. So I just click on it and I get there.
Yeah.
Okay, thank you.
Okay, so
room number 1.
I'm assigning only the entry staff, but all the participants can join the room, the room you wish.
I see all of them. So shall I go to room 1? Then you said.
You are
Tanya. I see all the rooms here when I click room 1 to 6.
Yeah, join one. Join one.
Good.
Yeah.
Okay, I'm in there.
Okay.
All right. So from my perspective, we are ready to start.
Yeah, please go to the breakout room and discuss and do the exercise, and we'll be back in 15 minutes. 10:40.
Please go into the HackMD. There's here's a questionnaire like ask is the speed okay? Because now we have a bit, some people say too fast, which I can understand. It's kind of overwhelming, all these commands. So we can adapt it a bit. Okay, and now we are here. If you can also find the HackMD, we are now here for the training pages, and then you should see finding things on the top. Okay, and okay, then I continue. Is that okay for everyone?
Please, Jørn. We will have a break at 11. I would like to keep it like that.
Yeah.
Okay.
Okay. So now we've learned a bit how to move around on the cluster, or like on the command line, and how to look at files. But one of the things which you currently you have to remember where you put a file. And now we will talk about how to find things if you don't know exactly where they are. And sometimes you, especially like in scientific calculations, you often have like complex folders and subfolders and a lot of files. And sometimes you just look for like an output file or something. So, and there's a command, but before we come to that, I'll created some folder structures, and it would be great if you could download those. So if you go to the documentation or the course page and then finding things, there's the first part is called setup, and there's 2 commands, and you can just copy them. And I will copy them here. So the first one is wget, which downloads files from the internet, because the files I prepared are now somewhere stored on one of our servers, GitLab. And by using the wget command, you download them. And you see here, this is a relatively small file that should be quite fast. Oh yeah, and should have said that before. You can see from the tilde here, I'm in my home directory. The tilde represents the home directory. So this pwd, you can see I'm in my cluster home, and then JD. So I download the file with wget. And now I have to unpack it because it's a packed archive. I will do this with the second command here. You can always see that my commands here at the top of my screen. So yeah, it should work. So with the tar command, you can unpack and pack folders and files into archives. In this ties, it's a tar gz archive, and with this command, you unpack those. Tar is a really confusing So even though I've used it for many years now, I still sometimes have to look it up because what kind of like letters you have to use here to unpack things. So now you see there's like and like a lot of folders and files with ls-l. You can see them. I should have prepared that a bit better, but here is a test data folder. That's the one you just downloaded and unpacked. So,
so sorry, Jan. Is it possible for you to show the web page where you copied from a little bit, or is your browser somewhere else now? Yeah. Thank you very much. So this is the place you're in. And is it possible for you to move the terminal a little bit, like the height, reduce a little bit? At least on my screen, I missed the last parts that you typed.
Should I leave the web page open or?
No. Now, this is where
so
you follow things. So yeah.
This is the web course page, finding things, and then there's a setup. And here are these two commands you have to type. So the wget to download and the tar to unpack it. Unpack it. Okay, now we will discuss the find.
On your terminal, the last line, it's difficult for me to see the. Now, if you type something now, it's difficult for me to see. Either you could
I don't know.
a little bit up, or maybe clear the screen next. Yeah.
Okay, I will clear the screen. You don't have to do this. It's clear. Everything is. It's not deleted, but it's just like you can't see anymore. So. Okay, now you should have a folder called test data. So with ls, you can, for example, here see this. The blue in my case are folders. So test data, here's the folder. I now have colors. I'm not sure if this is what. Okay, and now we want to find some files. And a lot of these commands are very confusing. In this case, I hope find has a really like name which is easy to remember and easy to like describe what it does. And I'm looking for a file called output.txt. And I know it's in the folder test data. So I'm still in my home. So now we will do this from outside the folder. I will write find and then the folder name. So where do I want to look? And it's called test data. And then I know the name. And find can do a lot of things. But if you just want to, the name, you can write -name. And then output.txt. So, and then you will see there's only one result in this case. There's one file called in the test data folder and a subfolder. They're all like random names. There's a file called output.txt.
So this is correct to say that the find will now look inside the test, only inside the test data, not all over the computer, all over the drive, and it will also look for subfolders.
Yes, it will look. So in this case, the command, the first argument you give to find is where to look. If you want to look in your current folder, you would write instead find and then a dot, because a dot in our Linux world describes the current folder, and then the folder, for example, here name and then output. Then it would look in all folders which in your current folder and all the subfolders of it, but it doesn't go up in the hierarchy; it only goes down. But it will always look in all the subfolders of the folder you're starting with. So now it's assumed that you don't remember if output was. So I will go down to the last command. You can do this if you press the up button in your keyboard. Then you don't have to retype the whole thing. So find will now look in the test data and there's a name output, but let's say I don't know if it was output was capitalized or all caps. So I'm not sure how it was written exactly. So I could now, of course, like look for the output because maybe, okay, no, I didn't find anything here. Then maybe it was all caps, output. Oh yeah, actually there's a file. Maybe there's another file. No, okay, so this is a file. But if you don't want to go through all the iterations, like all the possibilities you can have is like capitalization of different words and so and like file endings, then there is also another command or like the same command, also still find, so still syntax, but instead of just minus name to look for the precise name you give it, I want to look for the name, and it doesn't matter if it's capitalized or it doesn't. So it's called ignore case, and this is a minus I name. The I comes from ignore case. If I do this, then it doesn't matter now how I write it here at the end. If it's like all caps, it will ignore all of that. And then I find both of these files at the same time, because now it looks for output with, well, it's all kind of capitalizations. So this is often really practical if you forgot how a file was written, like precisely, if it was caps or low caps or. Okay, so then what you also often will find out if you look for files is that you might remember what kind of file you look, or you want to just list all the files which, for example, are CSV file. CSV are usually more like tables, for example. So let's assume we want to look for some CSV file, but we don't remember the name, but we know it's in the folder test data. What we can then do is we write find, and again test data for the folder where we want to look in, and then we want to look for the name. But now we know it will end in .csv, but we don't know what the name before the .csv file CSV was. So what we can use then is something called a wildcard. A wildcard is basically it will look for all the things which contain, or replace a wildcard with all kinds of possibilities. So the wildcard in our case is an asterisk, so a star. If I write this, then it will look for all files which end in .csv. It doesn't matter what comes before. So if I try this now, I will probably get an error message. Oh, it actually works. Because usually it's a good idea to put quotation marks around wildcards, because otherwise there might sometimes be weird things happening. So it's always good to put quotation marks around the name you're looking for. Now in this case, if I will have the same results, there's a lot of different CSV files. So if you remember, you're looking for a CSV file, now you can see all the files that there are, and then you can look at them one by one, or you can just recognize the one you want to have. You can of course also use this wildcard in this iname. So if you don't know if it's capitalized or doesn't, we'll still find all files which end in CSV. It doesn't matter if it's CSV in big letters or small letters. Okay. Should we say more about find?
I think you show the basics, yeah, so people can find more options, they can find modified date, when last change was happened. There's so many things that you could use with find, and you could combine other commands with find as well. I think you gave a very good basic understanding. So we can move forward, Jørn.
Okay.
Yeah.
Good, great. So yeah, look at the course page if you have any kind of question, because find cannot only look by file name, but also by other, the size or when you last modified, and you can also combine those things. So for example, a certain file is a CSV file with a size bigger than 2 megabytes or something you can look for. But here, find is generally really useful. But assume we don't know the file name, and maybe you don't even know what. Just assume with find we look for files based on usually on the name in a folder or in subfolders. And then there's another command called grep, which is unfortunately not as descriptive as find. And grep is useful for looking into files. So if you assume you know a line or parts of a line in a file, and you want to look for a certain sentence or a certain word or a certain expression. So in this case, I have a file called gene list. And let's first find it, this file, so that we know where it is. It's in the test data folder, and the name is genelist.tsv. We see, okay, it's directly in test data and then slash genelist. So, and now we will look for, it's a list containing different gene names and also the organisms they come from. And now we want to see all the genes that come from a rat. Okay, we can do this. Let's grep. And with grep, the syntax is unfortunately slightly like opposite of what this is in find. We first enter what we are looking for, in this case, rat, and then the file we want to search for in. And so it's the opposite of find, that you first give the file or the folder. genelist.tsv. Now we see there is one line which contains rat, actually in two places here, but there's one line. The whole file is quite long, but there's only one line which contains rat. But maybe there's like also rat with capitalized. So we can also look for that, because now I wrote it in small letters. And then we find another one. So now we have the same problem, or same. We now can look for that exactly the spelling we do. So if it's small letters, we look for small letters. If it's like starts with a big R, then we look for that. And similar to find, there's also an option here to ignore the case. And in this case, it's this -i for ignore case. So we can use grep and then -i, and then we write rat, and then the file we want to look into, or where we want to search for. And then see, now we see both of them at the same time. Okay, so now we know how to look for files and how to look in a file. But sometimes you want to look, sorry, yeah, please.
So then will it look for files everywhere, or is it only on the current folder?
So in case of grep, it only looks in the file we specify. So here in this case, it only looks in test data gene list and doesn't look like in any other file. In case of find, it always looks in this folder you specify. So either with a dot, the current folder and all its subfolders, or like in our case where we wrote test data, then it will look in the folder test data and all its subfolders for the file.
And these colors, the red color, would there might be some configurations that the color might not appear, maybe.
Yeah.
So that
the red color is only shows you the part you were looking for, so it's easy to find, like where's the red on the line, basically. Sometimes you don't see the colors, then I'm not sure, maybe then it's bold actually, but you can configure like colors, and we can look for it. I'm not sure if it's in the default. I thought it is.
Yes, but don't worry if you don't see the colors. We mentioned that in the HackMD, and then we can find some specific solution for you when it comes. And you could also read in the teaching material if you want to find the exact rat, the word rat, not occurrence of the word letters RAT. That also you could do that, Jørn. I think you have written about it in your.
No, but should I introduce it, or is it too confusing now?
No, just go ahead with your plan. Go ahead.
Okay. All these commands, find and grep, have a lot of options you can use to really fine tune your search and to look exactly what you're looking for. Often, what I do is often Google, what do I want to do? And then like grep or find, and then I usually find. Okay, but now we can look in a file and we can look for a file. So it's find and grep. But sometimes you want to look for a current, like a certain word or a certain string or like a gene name, like in this case, for example, for this. But you don't know in which file you want to, in which file it is. And you can also use grep for that. So you can use grep to look in a certain or a specified file here like this, or you can look in all the files in a certain folder, or all the subfolders. And that can be done with grep -r for recursive. And then let's, for example, look for this gene here. ASD 17B10, that's the nicest name. And let's say we want to look in all the files that I gave you in the test data folder, then we would just write this. So grep -r for recursive, and then the string we want to look for and the folder in which we want to look. And then this takes a bit longer because now we go through all the files. And now we see here there's 3 occurrences or 3 files which contain our string, our gene name. The one where we already looked at, gene list. So we know that one already. And then something called sequences.faster, which is some file. Maybe we're interested in that one. Or maybe we're interested in this one here, experiment notes, where it is on this line. And it would always print just the line that your search term was found on. But sometimes it's like nice to see a bit more information. In this case, we can write -c for context, and then let's say 1, and then we get 1 line around it. So in this case, we get the line and like 1 line above and 1 line below. And the same for
So
each
yes,
of our files.
I was thinking, because we are motivating the terminal a little bit. So if I had to open one by one, it would have taken a lot of time. So here I see a very good way that you are showing that if I want to find some text, it summarizes me what I wanted. So this is, I think what you're demonstrating is some motivation for us to learn the command line interface.
Yeah, I think oops, sorry.
Yeah, no, just reminding you about the time. So
Yes.
how about the exercise? We will ask the participants to do it by themselves after the course. They can have the solution also. And then after this, we can go for the next session. How do you think, Jørn?
This is fine. So there is I will show the web page again.
Yeah.
There is here on the finding page, no, it's not now perfectly centered, but on the finding page, you will, at the bottom, you see an exercise. I try to keep it realistic. So there's 5 different questions, and there's also solutions. So if you want to do it on your own.
Yeah.
Okay, that's all I wanted to show you.
Okay.
Grab and find.
Well, thank you, Jørn. And I think it's time for us to take a break, 10 minutes break. We can back after 12 minutes past 11. And we will start with Sabry's session, reading and writing files. Okay.
Yes.
Okay, Daniel.
Yeah, thanks. We'll be back at 12 minutes past 11.
Dania gave me a signal when everything's ready.
Yeah, welcome back. Everything is ready. I just wanted to mention that we are skipping the exercise part of the finding things session, and you are requested, all the participants are requested to do by your own. And Entry staff will be available after the last session on the Zoom rooms and breakout rooms, so that we can ask for support or discuss something if you wish to. Just wanted to mention, and then I'm handing over to Sabry for the next session, creating and modifying files. And this will be type along, as I understand, right, Sabry?
Yes, Dania, thank you.
Yeah, thank you.
So then, Jørn, explain this finding files and the command grep. So I'm going to go to the next lesson now. The next lesson is creating and modifying files on the terminal itself. So without moving away from the terminal, we can create and modify files. So who's joining me here, Radovan or Jørn?
I'm here, Radovan, present.
Yeah. So Radovan, I'm going to show several methods that we can create files. So when I do the command, I'm expecting the people who follow also try it and give their feedback on the HackMD. So the first part I will explain, and I'm going to skip the second part and go to the terminal editor, and then come back to the cat, the middle part if I had time. Because the focus here is actually the terminal editor. The other two is to sort of explain the rationale behind quickly generating text files. Radovan, will you be explaining about redirection later on?
I will show it in
Yes.
the next episode. I will show how we can, because right now we have been using a couple of commands and they created output and the output went into the terminal, but sometimes we want the output to go into a file. But it's good that we show it, that it's good if you show it, and then I will show it again later.
Okay, now first I'm logging into Saga. Now I'm in Saga. Let me fix my terminal to the middle a little bit. Let's move it. Yes. Okay. So I'm in Saga Radovan. Let's try to use one of the folders that I already created. So I forgot what the folder name is. I'm going to use one of the commands that we used already just to find the file. Okay, it's called test data. cd test data. And I'm going to clear the screen to take it to the top. So I log into Saga and I found a folder that we already used in the course. So I didn't want to create another folder. So I'm going to do work inside that. So if I use the command, there's a command called echo Radovan. What it does is it echoes whatever type here directly onto the terminal. It prints there. So with Unix redirection that you will talk more later on, I could send this content to a file. For example, if I want to send this content created with echo to a file, and let me make it a little bit bigger. Yes. So if I type that, it prints. So instead of that, I use this less than sign, and I'll give a file name. New file with echo. So what will happen, Radovan, is I try to be more like explicitly as possible to say that I'm going to create this temporary file with echo. But what do you think will happen if there's already a file with that name?
Yeah, this command will create a new file. And if there is already one with this name, then we will lose it because it will create a new file with the name.
So let's look at that file using the command that we learned before. New file with echo, and you see this content. Then I want to append something to add more content. Append. My intention is Radovan to add one more line. I press enter.
Yeah, but now we made a mistake, right?
Yes.
Because
so
we didn't append.
So if I want to append it, that you will talk later, I think more. So I'm going to create the file again. And this time when I say append, I'm going to use this double redirection. Then you'll have both.
Sabry, may I suggest that you type ls after each command?
Okay.
So that people see.
Yeah, so sorry about that, because I'm using already a folder, so I didn't create a folder. So you'll find the file I'm using. Yeah, new file with echo here. Or I should have actually created a clean folder maybe. So then the next one is because now it is one line, for example, if it is it is a single line that you want to send to a file, it's easier this way. But if you have a lot of content, it will be very difficult to sort of do this one by one. So that's why we need a terminal text editor. So as Nikolai mentioned, maybe I will create a new folder. I'll call it exercise. with okay, let's call it editor test. What I did was I went back to my home directory and I created a directory which we maybe did we show the make directory command, Radovan?
Yes, but briefly. So it's really good that you repeated it.
So so here what happened was I created a folder or a directory, and I'm going to create a I'm going to change to it using the commands we learned earlier. Now I can use the ls better. So to motivate a little bit, so I'm going to open like a graphical sort of a text editor. So this could be my Microsoft Word, or this could be any other text editor, like a document editor. So I'm going to type the word test in this with the. I'm not going to enlarge the text because the reading the content is not that important. Then I'm going to.
So wait, just to clarify, so the thing that you just opened, this is now not running on Saga. This is on your computer, and in this case, people should not do the same thing, right? Because they might not have LibreOffice.
That is a very good point, Radovan. I'm sorry about that. So the thing is, I opened it on my laptop, not on Saga, with the mouse. I clicked something, and I'm going to save it on my desktop and call it test, and I'm going to save it, and I'm going to close the document. So in my document on my laptop now, I have this file called test.odt. If I do a cat command on that, you will see that a lot of metadata inside. So what you see with your eyes and what the file content is there as the computer see is not the same. So when we work with the terminal, it's very important that what you see and what computer understands in that way is the same. So that's why we need a terminal text editor that does not add all this metadata information. Was that a little confusing, Radovan, or should I?
No, I think it was okay, because I think what you showed is, I think how most of us edit files. We most of the time edit files on our laptops, but now what we want to do now is we want to create files and edit files directly on Saga, and we will avoid. I mean, we could create it on our computer. We could copy it over to Saga. We didn't show how. We will come back to that in the following days. But here we will be able to create the file directly on the machine. So we will save us some steps, and also we will create an actual text file.
Yes. So thank you for that, Radovan. The thing is, the point I wanted to make is, if you're going to make your files on your laptop using Microsoft Word or LibreOffice, for example, and if you transfer it to Saga and use it as a batch script, for example, in our next lessons, it might not work because there might be a lot of metadata associated with it. So you should not. So that is one rationale that we are trying to learn this terminal editor, which is sort of difficult to, so not intuitive, but you have to learn it a little bit to have this plain text content. For this, the editor we are going to use is Nano. So Nano is not the only editor, but we have like Vim. I usually use V or Vim because it's more convenient, but Nano is easier to learn. Which editor do you use mostly, Radovan?
Sorry, I was typing and need to unmute. So I use VI, but it is not the easiest editor to start with. So we recommend to start, if you are new to text editors, we recommend Nano as probably the easiest to start with.
So I'm going to do ls to start with to see there are no files already present there. Then I will use the command nano, that is the name of the program. And then I'm going to give a file name to start with. So learn nano.txt. So the file name, if you don't give a file name, Radovan, it will still open, but then when it's trying to, when I'm trying to get out of Nano, it will ask for a file name. So when you are learning, it is better that you start with the program and the file name that you want. Now, when you start typing this file would not contain anything, it's empty file. But if if there's already a file, it will not overwrite like as in our echo example, but it'll open the contents. So I'm going to open it with Nano, the file name. At the end, I'm going to press the enter key. Right. So I land in this sort of very cryptic place where there's a sort of a blank window with a blinking cursor here, if you can see it. And there are some shortcuts. So there are no menus that I could go and click. So I had to use these shortcuts. So when you land here, you could type like new content, second line, and you could press the enter key to have a new line. Then when you have 3 lines, I can move the arrow key 3 times and up to the content. So it will not go past what I have typed. And I can use the up arrow, down arrow, left, right arrow keys to navigate. But I can't go, if I press the down arrow key further, it will not go because there are no lines there. So here there's a character as well, which we couldn't see, a new line character.
Yeah, nice. So now we have a way to create a text file directly in the terminal, and this is something we will need in the following days when we create run scripts. Then it will be very useful.
Yes. And then we have some shortcuts here. So we are going to learn only 2 shortcuts today. Others we will sort of give you as homework to sort of investigate. One shortcut is write out. In Nano language, write out means save, Radovan. So unfortunately, they have made it this way. So Control O. So this means the hat here and the O here, it means you have to hold down the control key on your keyboard, and without letting the control key go, press the O, Control O. And then it will pop up for the name. This is the name that you mentioned. And here, for when you are learning, it is important that you don't modify what you display here. So what displayed here is the file name. Without modifying, press the enter key. Now it would say wrote 3 lines, 2 lines that you could see and a new line that's there but not visible. So it has written 3 lines. Control O to save. And to come out of this editor, hold down the control key and X. You can see that shortcut here, Control X.
And what if I forgot to write out and I do Control X, exit?
Yes, so I'll go out and come back again. So Control out, I go. Now there was no argument, and ls again. The file is there. Let's view the content with the cat. So the content is there. So I'm going to open Nano again with the file name. So this time, Radovan, it will open up with the last content. So here I'm going to have the 4th line. Right, number 4. And I'm going to press Control X as you suggested without saving it. Then it will warn me, you have modified the file. Do you want to save it? Press yes. Do you want to press, you don't want to save it but get out? Press no. If I say no, I will lose this text. Or cancel, just take me out of it. That is Control C. So Jørn mentioned that times ago to get out of things. Mostly Unix, if you're in a predicament situation, if you don't know what to do, usually take me out of here quickly is Control C. So Control C would bring me back to the terminal here, the Nano editor here. So I'm going to save that now. Control X. Do you want to save it? I press the Y on the keyboard. Yes. And then it's asked whether you want to use the same file name. So don't edit the file name. Press enter. Now let's see the content. Now we'll have the content here. So I would recommend that you also try it. Open the terminal or Nano editor and try to edit something. So I'm going to pause 1 or 2 minutes, or maybe talk something with Radovan while you do that. Let me check the schedule a little bit. We have up to
11:40, Sabri. You can use.
11:40. Okay. So try it out. So Radovan, this Nano is very good to learn, but it's enough. It's enough to get by. So for the batch scripts and everything, it's enough to get by. But for programmatic, if you're using scripts, it's more convenient if you learn a more editor with more options. But knowing Nano would be adequate, in my opinion, to get by. What do you think, Radovan?
I completely agree. I think it is a very good starting point. It is very limited, but that is good at the beginning. At the beginning, we don't want to be overwhelmed. I think eventually, if you spend a lot of time editing files, maybe eventually you will want to have more. Then have a look at the other available text editors. Also, spend some time finding out which one fits best to you, because you will hear people saying, oh, Emacs is a lot better, or VI is a lot better, or Nano is a lot better, or the Visual Studio Code is a lot better. I recommend to spend some time, find out which one do you like best, because it's also about personal preference. And many of us spend quite a bit of time editing files. So I think it pays off practicing this a bit, exercising and learning shortcuts. In Nano and in all the other text editors, you can also turn on highlighting, so you can use colors that will help you editing bash scripts and other programming language files. So I think this is time well spent to learn one of these editors really well. But Nano is maybe the best starting point.
Yes. So when I said this file name, so this is the program, and we call this an argument to the program. We give it the file name as argument, so that file will be created. But that file will appear only if we save it. And another thing, Radovan, is this $sign at the end of this our prompt. We never sort of type that in. It's just something that should be there. So some of the commands, it might say $nano file name, but we should remember that we don't type the prompt. You only type the command and the argument for that. Is everybody okay? Can you get some feedback on the editor? So whether people need more time, or if they're okay, let's see the HackMD. Yes, if you're trying other editors, go ahead and use the HackMD, but I don't think we'll have time to explain them during this session. Yes, so there are other software that you could use as well. Okay, so then I will show another part that I skipped in the beginning. The cat command that you use to view files, you could also edit. The reason that I'm showing here Radovan, is the cat command, the concatenation command. Is sort of meant to combine multiple files and create one file. So I want to show that part. That is the reason, because if you have a lot of Unix files that you want to create a big file out of it, there are some bioinformatics files that you want to sort of collect into one place, you could use this.
Yeah, it's a fantastic command to stitch files together. Like you have 5 different files and you want to make one big out of it. Cat is wonderful for this.
Yes, stitch is the word. Thank you for that. So I'm going to create the first file now. So when you open the cat, I'm going to, there's a difference between how I'm going to use cat here now. Here I said the command and the terminal, the argument, which is a file name. Here I'm going to use the redirection instead, and new file with cat.txt. So when you press enter, you will get into a mode, editor mode, and everything you type here will be saved in that file. This might be confusing if you are using this the first time, but let me demonstrate that. I'll type the character A here, B, C, and a new line, sorry. And then to get out, as mentioned in the material as well, hold down the control key and press the D. Control D. Then I'm going to get the same command with the up arrow, and I'm going to remove this redirection. So cat will function as a command to print, and it will print this command. And if you see the last line that I entered is not there, like in Nano. So the content is like this. And if I do the cat again, it will overwrite the content, and you don't usually use it to like sort of append things.
You also mentioned this up arrow, so that is very interesting. That went very quick. We should. Can you say again what did that do when you press the arrow up?
So in the keyboard, Radovan, we have 4 arrow keys: up, down, left, and right. In the terminal, there's a history that is recorded every time we type something. So if you click the up arrow key, you can go back in history what you did. So
and what if I want to? Oh, sorry, didn't want to interrupt. Go ahead.
Yeah, go ahead, Radovan.
And what if I want to see the history and I don't want to go arrow up, arrow up, arrow up? Or what if I want to see what I did? So what I'm is that there is a command history. Might be a good moment to.
Yes, so the history command is there. So I'm going to let you show that. The reason is, if I show it now, I need to pipe it to a head.
All right, I will show it then in a moment. So
yes,
so there is a way to see all the commands that we did. Yes.
So and I didn't check my history to show live. So I would have prepared. I will make sure that what my history displays is what I want to show online, for example. Because I'm not ready for that, I'll let you show that when you do the piping. And then I'm going to, let's see if I want to see what, so let's see the files, ls, and cat learn nano is there, and then cat new file is there. So if I want to combine these 2 files, Radovan, to create a single file, I can say cat, the 2 files, right? And as the last argument, so I have I went 1 line below now. So here, this is the same line, still continues. I give the last argument as combined.txt.
Wait a moment. So this will not work. But maybe you know that because maybe first try without the combined. What happens if I concatenate the 2 files? It will.
Yes. So what I'm going to do is I'm going to okay. Let's do that. It prints everything one after another. It doesn't have a it didn't sort of create a new file, but it printed. But if it is a very large, if it was 2 very large files, it will fill my terminal.
Yeah, and now what we want to do is we want to actually redirect it into a file called combined.
Yes. So, but I don't have a file like that. So I don't have a file yet created, and I'm going to just type 3 files here, and what it would say is at the end there's no such file, because if you remember when I did echo that you will talk more, that you have to redirect this to the file. So I missed that part. So the last argument should end with the redirection. Then what will happen is it will create, okay, ls first, as Nikolai remembered, remind me in the beginning to show that it's created, and then cat combined. Instead of redirecting, instead of printing it on the terminal run, it has now created a file. So this will be nice if you have like even 10, even 100 files, combine them, but it will be in the order that you give it. So those are the 3 things, Radovan, that I wanted to mention: echo, cat and the nano as a text editor for different purposes. Is there anything more that you would like to mention about these things, or maybe I can show you something interesting that some Unix people do?
I think I'm pretty happy, but it would be nice to see something interesting. I will also use this 1 minute to just get a glass of water for the next session. So just that you know that I'm going for 1 minute. You don't talk to the void.
Yes. So the thing is, this people who make these Unix commands, they have this sense of humor. So sometimes they sort of do things like, let's say if you have cat, it prints the file from top to bottom. So then somebody went and created a command called TAC, the opposite of cat, to print from the bottom to top. So there could be things that you might find interesting, sort of like Easter egg sort of things when you go and learn these commands and investigate how these things work. So I hope that you got some idea about how to create a file with a single line or 2 lines in a quick way, or to sort of use an editor like Nano to create a more complex file like the batch script that we'll learn in the following days. And that you should not use a graphical user interface that is made for document editing to create files that should be used on the cluster. So Dania, you can have the mic now. So
yes,
I
am Radovan, are you back?
Radovan will be back in another 3 minutes, so you can take it over. Yes.
Yeah, so I just want to mention the next session also, due to lack of time, I would suggest we could go with the lectures and you do the exercise by your own. Maybe after sometimes Radovan can do the demo, and we will go with the schedule. Like after the break, Jørn will show you the scripting session. So, and we will be finished by 12:30. And if you have any questions, we will be around in the main room as well as in the breakout room. If you would like to ask questions or get support from anything, and you will get an email later today. And HPC sessions will start tomorrow. So that's all I want to say. And please ask questions. We like to get more questions so that at the end of the course, we requested you to say if you like what you like from today's lectures or what you liked us to improve. So there will be a question at the end of the HackMD later. Jørgen, could you do that after the session or during now also? Then you can give your answer so that we can prepare ourselves tomorrow better. Okay. Is Radovan back?
I'm here.
Okay, yeah, that's great. Okay, please go ahead, Radovan. I was just saying that we will go to this exercise. The participants will do the exercise by their own. So you can use the extra 3-4 minutes for demo.
Sounds good.
Yeah, thank you. Please go ahead.
Screen sharing now. Okay. Yep. I will now go into the episode composing commands with pipes, and I understand that we will go until 12 o'clock and we will take a break then. And it's not a big problem that we don't have time for the exercise, because the exercise is, it has a solution. Out of the many solutions. I encourage you to try it. We will use these 15 minutes that we have to demonstrate how we can compose commands in Unix. And this is one of the things where Unix really shines. We will show how with relatively simple commands we can build arbitrarily complex pipelines by chaining them. Maybe somebody can help me. Oh yeah, it is already there. So in HackMD there is a link to the episode where I am right now, so I can create some space here for me and close this window. And I will now start on Saga. I cleared my window with CD. I go back to the starting point to my home folder, and if you want to type along, on top of the piping page, there is again 4 commands that I can use. So there is the CD, then there is the wget to fetch the example. Let me copy. This one will fetch an example file. And then with tar, we can extract the archive. It's similar to a zip file, really the same concept. And with CD, I can go in. I want to show you a bit more of my history. So then I'm in my home, I'm in exercise pipes. And also, I think Jørn is with me. Please ask me questions, relay anything that comes on HackMD. We have, in Jørn's sessions, we have seen 2 commands that I will reuse again. One was find, to find files in on my file system. The other one that we have seen is grep. With grep, I can look for certain lines, certain text portions in my files. And an example, so let's see that again. In my exercise pipes, there is a file called RGB. The RGB, it's a long file with colors, different colors with different names, and their color code in hexadecimal. Here we are only interested to have, I wanted to have a big file with lots of similar names. What if I want to now only see the lines of this file that contain the word blue? Grep blue RGB, and here I'm following the material. This will show me only the file, only the lines that contain blue, and here they are. I want to introduce 2 new commands. One is to sort a file. Sort, I can sort a file alphabetically, even alphanumerically. So sort has options, you can check them out. This will sort the file and print the output to my terminal. So this is now alphabetically sorted, all the different colors. Yellow is on at the end, and at the beginning there will be something with A. In this example folder, I have a file called repetitive. What is in this file? Cut repetitive. This file contains some repetitive lines. And there is a useful command called unique, spelled surprisingly just 4 characters, that you can use on a file, and it will remove line repetitions, but it will remove consecutive line repetitions.
What do you mean with consecutive?
Meaning that instead of 5 lines with some text, I only have 1. But what it didn't remove, these are not adjacent, they are not next to each other, so it didn't remove them. If I really wanted to not see any duplicate lines, what would I do? Is it already the right moment? Maybe.
We could basically first sort it and
Yes.
then save it in a file and then run unique on some file, on this new file, and then have like the output.
Good suggestion, let's try that. So I could do sort repetitive, and I could put it into a temporary file. Okay.
Is it important that it has like a txt ending, file ending?
No. This was only for, it doesn't matter to the file system, it matters to, it communicates to the human that this is a text file that I can open and read. So this is how I like to call it, but could be It has no other meaning than that. So I could do this. I could redirect it into a temporary file, and then I could do unique temporary file. And then first, since I sorted everything, and then removed line repetitions, I'm only 3 lines left. And now the point of this episode is that I don't have to do it in 2 steps. I can chain commands using pipes. And a pipe in Unix looks like this. Let me show you that. So I can do that in 1 step, sort, repetitive, and then I can pipe it. So it's the vertical line, and on my keyboard, it's just above enter. And I can pipe that into the next command, which is unique. So
on the Norwegian keyboard, it's below the escapes on the top left corner.
Oh, good point. Yeah, I'm on a US keyboard. Thanks.
Yeah.
So this is really the take-home message from this episode. I can compose commands arbitrarily, and the output from one is piped into the next output. So let's have some fun with that. There is a command called word count. I can use it to count how many words there are in a file. Okay, there is some output. I don't exactly know. I think maybe this is the number of words. I'm not sure.
I think it's first the number of lines and the number of words and then the number of characters.
Ah, good. Super. What I'm here after is that there is an option called word count -L, and I can use it to, if I only want to see the number of lines. So there are 951 lines. And if I now want to know how many colors blue are in this file, I can do it like this. Grab all the blue colors, and you can use quotes or not. The quotes will be important once you grab for something with spaces. So here it doesn't really matter whether they are there or not. If I do this, it gives me all the blue colors, but now I want to count how many are there. I pipe it into the word count -L. And it will tell me there are 136 blue colors. And you can now, instead of having that on the screen, Sabry showed us that we can redirect into a file. Maybe I want to have all blue colors in a separate file. Or let's have, I want it like this, colors txt. And now I want to have all the green colors. And if I would now hit enter, what it would do, it would overwrite what I did. It would create a new file with only green colors. So what I wanted to do instead is I wanted to append. I want to have first blue, then green, then red. And in this way I can, with this double, I like to think of it as a funnel. I don't know whether it helps. So it's larger than, here I'm appending to this file, I'm appending again. And if I would look into the file, I would first have all the blue colors, then all the green colors, then all the red colors. And let's have a little bit more fun with chaining commands, because you can chain them as much as you like. So in this file called repetitive, I could ask a grep for everything that contains line in repetitive, pipe it into sort. Okay, now I have everything that contains line and is also sorted. Now remove, pipe it into unique. And now how many are there? Pipe it into word count. Actually not sure what this is shown 4 times. I think I have some bug here in my history preview.
So there's no 2.
There are 2. There are 2 unique lines that contain the word line.
And is it possible now to also, like, after you piped it, to funnel it into a new file? So can you
Absolutely.
combine pipes and redirects?
Absolutely. So now, how many lines? And now I got the result in the file. Okay, and something that I mentioned in the episode before, because now as I'm composing more and more complex commands, sometimes I remember that, oh yeah, I used this really cool command with 5 pipes in a row, but I don't remember how it was. One way to find out is I can do arrow up and scroll through my history, but this will be really tedious. There is this command called history, which will show me, well, let's see what happens. In my case, it shows me the 1080 last commands I typed, when I typed them, and what was the command. So there's one way of remembering what did I do on last week. You can pipe the output from history and grab through that. So if there was this command and I did something with, I remember it contained blue, but I don't remember the rest. So now it shows me all the commands in my history where I did something with the word blue. This is incredibly useful. 5 minutes left. Maybe we can do some more piping with find.
Yeah, please, Radovan, mention the exercise as well.
Yeah, because that you will need for the exercise. Or should we go straight into exercise? And maybe it's more fun if people try the exercise on their own, but let me show you, because the command find is very nice with pipes. So what if, well, let's have a look here. What do we have in this exercise folder? Find dot. It will show me everything that exists here and below. Okay, there are some files, and I have a folder called calculations, and there are some files in there.
Can you explain what did find dot now do? Because we always look for like some name. Now you didn't specify any.
Yeah, if I don't specify anything, it will show me everything. Everything here, so dot means here and below in all subfolders. So these are all the files and all the subfolders in this place. This is equivalent of typing this. It's the same thing. And now if I remember what Jørn showed me in the episode, I can search for certain files, for instance, by name. Name, find all calculations that contain error in the file name. Okay, there are 3. But what if I don't remember what Jørn showed me? Well, I can take the output of find and I can pipe it into grep. So 2 ways to achieve the same thing. And in Unix, there are so many ways to achieve something. And but here I composed.
With grep, you did not look in the files, but you looked in the output of find, so the list of files. You did not go into the files, which we did earlier with grep.
Right. What I did is that I took the output from find and I used that as an input to grep. So grep looked, whatever came out of here, this is what grep used. There is one more incredibly useful command that is a little bit advanced, but I think good for you to know that it exists. Sometimes I don't want to run one command on everything that came out of find, but I want to run a command on each of the results from find. Let me explain what I mean by that. Let me clear the screen a bit. Let me find first in calculations, in the folder calculations, let me find all or I want to see only files, not folders. Type F. This will list me only the files. And now if I want to, I mean, I can now run, I can pipe this into grep or something, but what if I want to run a specific command on each of these? I can do that with xargs. I will now count the number of lines for each of the individual files. And in fact, each of these has 3 lines.
How did xarg work? Because now we had 1 pipe, but 3 commands, if I counted it right. So find is a command and xargs is a command and wc, or?
Yes, so xargs, yeah, it's an advanced command. It's actually not even the only way to achieve this, what I did here, but it takes anything separated by lines or spaces, and it will apply whatever comes next, it will apply to each of these. In the exercise, we will ask you to find all the files that contain an error in the output name, in the file name. And then for each of these, find or print the last line. And then one way to achieve this is with find, piping it into xargs. It's not the only way. So this can be really useful if you have lots of files and you don't want to go through each of these. You want to get a quick overview over the calculations that failed or the successful calculations, and you want to know why they failed. What important thing did I miss to mention? So now we have 12 o'clock. Exercise will be for later. There is a solution. Maybe I can open the website and just a sec, I will open it up and no, that didn't work because I copied only part. Zoom was in my way, just a second. The real power of Unix is, if I go back to the end of the to the end of the episode in the key points, the real power of Unix is that the philosophy is that it gives us typically, I think if I ask my colleague, everybody remembers maybe 20 Unix commands. I don't remember more than 20. They all do one thing only and one thing well. And instead of giving me programs that can do everything, but which I cannot change and cannot reassemble, instead it gives me simple commands that I can combine, compose to whatever I like to do. So try to connect your, I don't know, Word with some other program. That will be hard, but try to connect grep and ls. That is very easy. So that's really the power of Unix. Thanks for listening.
Yeah, thank you, Radovan. I just want to mention again that please do the exercise you're on, maybe after the lessons today, but we will keep the time schedule as per, and we will have a break now until 12.
Okay.
Yeah.
Then
Jørn, please take
yes.
over. Yeah, thank you.
Okay. So you've now worked on this page, and I will go to the next, which unfortunately you can't see, which is the page called scripting. And so now we've learned how to, we learned a lot of commands, and we learned how to work with these commands, and also that you can combine these commands. And now we will how to reuse commands and how to save them and share them. And for that, I will use the same folder I used in my first part called test data. So if you followed earlier, you can just go into your home directory, so just cd, and then into cd test data. Or if you haven't done this, you can download the things here. So it's on this page. Okay. So if I do ls, I see there's still this folder test data, and I will cd into that test data. So there's a lot of files here. And one is here, this one, this list.sh. That's a shell script because we will now talk about shell scripts. Because we now learned like you can write complex commands with like a lot of pipes and output files, and maybe actually like you want to have multiple commands, like issue multiple commands after each other. Maybe you first want to cd into some folder, and then you want to like find some or like display some things and sort them and do like maybe then do calculations or something on top. You don't want to like rewrite all these like at the same time, like all the time, or you don't want to, if you want to share them, you don't want to give your colleague like a note, like a written note or like a Word file. But instead, you can write shell files or shell scripts, and usually we denote them with this .sh ending. So let's have a look. I can display the file with cat. And then we see, okay, it's rather short. There's some cryptic line here at the start, and an empty line, and then this is a comment because all lines starting with an hashtag, or I think nowadays it's called hashtag, are ignored. And then we have here 3 lines of actual commands, which we can use on the command line also by itself. So it's an echo, so it will print this, and then a pwd, so print the current working directory, and afterwards ls, and here a wildcard again. So what this does is it lists all the PDF files. So it's similar to find, but it's only in the current folder. So I can like do them one by one. I will copy this, and then you will see, okay, it just does it, and I can do pwd, and then I can do ls wildcard PDF, and then I will see 2 PDFs being displayed. But this is now like, this is a bit of a pain if you want to like do this every time, and you have to like find the command. You can go up and up and up, but this is like already bothersome. Instead, we use this shell script, and we can just use this with bash. So bash is our terminal flavor, and it can also be used as a program. So you can use bash and then list.sh, and then it will run these 3 commands which are specified there. It will ignore the comment which was in the file. It will only run the commands. So it does what we want. It prints something, it states which directory we are, and then it prints out these 2 PDF files which are in the current folder. So this is really nice and dandy. You can just write some text file with your editor, nano, and save it, give it a .sh ending. That's not necessary, but it's like, then you recognize and everyone else recognizes better that it's a script. And then you can now share this file with either colleagues, or you can just reuse it in the future, and you're sure you don't like mistype or you forget something. Yeah. Okay. But so far we've seen that all our commands like find or sort or unique are all just like a command, and not what we now have is not a command. It's a bash, and then you have to write bash and then list.sh. So it doesn't behave like a command, but we can make it feel more like a command by just calling it directly, like list.sh. No, it doesn't work. The command is not found.
Because there was some discussion about using extensions, for example, because Unix doesn't really care about what you call the file.
Yeah.
But usually do you use .sh as the extension to sort of inform humans that it is a bash script, or is there best practice for that?
Yeah, so the best practice is to use file endings, file suffixes to inform humans about what a file contains. Is it a text file like txt or out? Is it a table? Is it like CSV or a PDF, for example? And for shell scripts, which also basically just text, this .sh for shell is commonly used so that you know immediately, okay, this is something you want to, you can either run directly or you want to use it like this bash and then script, whatever. So it just makes it clear this is something which you can execute. So, and so now we try to execute it directly, and that doesn't work because the shell, so where we always write our commands in, only looks at like certain places. It doesn't look in the current folder where we. So to say that, to make it like use the data, the command which is actually in the same folder, you have to first say, okay, it's in this folder. It's like dot, so the current folder, and then the name is .sh. And then it will try to run it, but now we get a permission denied error. And you might, even if you don't write shell script, but you just like use ones from other people or you download programs from like online, you will sometimes get this permission denied error. And it's the reason for that is that to be like used as a program so that you can execute it directly, it has to have the rights to be used as an executable. And we can check that with ls -l that we've seen already a couple of times. We see that here, but there's our shell file. There's like a lot of stuff. So the obvious thing is like it's a name in the end, and then okay, this is like some kind of date, the last modification date, and this is the file size in like not so super nice units. So what we can also do is -l and h for human readable, and then we actually we see something which is a bit more easier to see. Okay, here, so it's still 94 bytes, but the others have like yeah. And then there's, especially on the servers, this is like important. The user to which this file belongs in the user group, you can see all this like in the course page is described here, and then this kind of stuff here. And that tells us what rights this file has. So in this case, the first 3 or sometimes 4 characters, show you what this file can do. So in this case, it's R and W, R for read. So you can read this file and just like display it with cat, for example, or with nano. And in this case, I can also write the file. So I can change it. And then there is a dash. And this dash is what makes this file not an executable because it's not executable. So if you want to change that, so you can run it directly. We can do that with change mod, chmod, and then we say it's +x for plus executable flag basically. And then we have to write here list.sh. And now if we do ls -h again, oops, sorry, -h, then we see now suddenly, in my case, the color actually also changed. Here is R, W, and X. So in this case, now I can also execute it. I can read, I can write, and I can execute. And so let's try that. I still have to like specify that's in this folder in the list.sh, and now it runs the script. So it does the same thing as if I just write bash.list.sh or without the /. It's just another way of, it behaves more like a program in this case. Okay, so our script works. I think also now we have 10 minutes for like a really short exercise.
Yeah.
I'll show you here.
So I request all this, all entry staff which were in the rooms earlier, please join their respective rooms, and participants to join the room they wish. We will wrap it up, and I will stop recording, but we will be around after 12:30 for half an hour if you have questions or something.